Hello, NotebookLM users and AI enthusiasts. Today, we're diving into another powerful use case for NotebookLM, but this time we're doing things differently. If you haven't been living under a rock, you've probably heard about DeepSeek, the AI startup sending shockwaves through the industry. But its impact goes far beyond tech. DeepSeek just triggered one of the biggest single day stock losses in US history, with NVIDIA's market cap taking a record breaking hit. How did a small startup from China unleash this kind of chaos? To find out, I turned to NotebookLM. Here's my notebook, packed with news articles, blog posts, X threads, YouTube videos, and, most importantly, technical papers on DeepSeek's latest V3 and R1 models. Then, I ran a prompt to generate a podcast-style breakdown of what's really happening. Get ready to deep dive into what makes DeepSeek's R1 model special. We'll break down every key technique in a simple, easy-to-understand way, how it's shaking up the AI world, its potential impact on the industry. This is hands down one of the most mind-blowing ways to learn complex topics. Let's get started.
Strap in, everybody. We're going deep on AI today. Specifically, this DeepSeek R1 model that seems to be everywhere I look. There's a lot to unpack.
There really is. And it seems like AI is changing by the day. DeepSeek is definitely right there leading the charge.
So let's start with the basics. Can you give us a DeepSeek 101? Where do they come from, and who's the brains behind it all?
DeepSeek is a pretty new company, actually, founded just last year, end of 2023. The founder is this guy, Liang Wenfeng.
What's his background?
He was get this, a hedge fund manager.
Really? That's not your usual AI founder story.
Not at all. But Wenfeng has always been into tech, always saying how it could completely change, like disrupt industries.
Okay, so not your Silicon Valley tech bro.
Nope. Which maybe explains why DeepSeek is doing things so differently. They don't seem to be playing by the same rules as the big AI companies.
Interesting. Now, DeepSeek has a few different models out there, but R1 is the one everyone's talking about. What makes it so different, so game-changing?
Well, a few things. First, R1 is super cost-effective. They're getting similar results to models from Google and OpenAI, sometimes even better, but the cost is way lower.
Yeah, in one of the articles, it said they only spent something like $5.6 million to train their base model, DeepSeek V3. That's nothing compared to what billions the big companies are spending, right?
Right, and it's not just about spending less, it's how they're getting these amazing results that's shaking things up.
So let's get into the tech stuff. What are some of the things DeepSeek is doing that are so groundbreaking?
One of the big ones is that they use pure reinforcement learning, or RL, for the early training. Most companies rely on a supervised fine-tuning, SFT, but DeepSeek went a different way.
Right, so SFT is kind of like feeding the model a ton of data, showing it the right answers, and RL is more like letting the model learn by figuring things out on its own.
Perfect analogy. They built this system where their model, DeepSeek R1 could test out solutions to a problem, try different things, and get rewarded when it came up with a logical answer.
Like a kid learning through play, right, instead of just being told what to do.
Exactly. And it looks like this is leading to some pretty amazing learning and problem-solving abilities in AI. The DeepSeek researchers even wrote about what they called an aha moment that happened during training with R1.
Hold on, an aha moment. Like the AI had an epiphany or something.
Yeah, it sounds wild, right?
Yeah.
But they saw that during the training, the model actually started dedicating more processing power to the tougher problems, almost like it realized, hey, this is hard, I need to focus more here. That kind of self-awareness, even if it's not like actual consciousness, is pretty remarkable.
I can see why people are calling this revolutionary. But if this pure RL is so great, why isn't everyone doing it?
So their first attempt was purely reinforcement learning.
Okay.
They called it DeepSeek R1.
Mm-hmm.
It achieved remarkable results,
Okay.
but had some quirks.
Oh.
For example, it sometimes mixed languages in its responses
Oh, wow.
and struggled with readability.
So it was super smart, but a little rough around the edges.
Exactly.
Interesting.
So they incorporated a bit of supervised fine-tuning in the final model,
Okay.
using a small amount of carefully curated data to smooth things out.
Interesting. So it's a hybrid approach?
It is.
But didn't they risk diluting the benefits of reinforcement learning by adding in supervised fine-tuning?
That's a great question.
Yeah.
And it's something they considered carefully.
Okay.
They found that a small dose of supervised fine-tuning was actually beneficial.
Okay.
It helped the model learn to generate more human-readable or
Okay.
coherent responses without sacrificing the core reasoning abilities developed through reinforcement learning.
So it's a balancing act.
It is.
Okay, let's talk about their 4-stage training process.
Okay.
It all starts with something called a cold start phase, right?
Yes, the cold start phase is like giving the model a bit of structured guidance
Mm.
before unleashing it to learn on its own.
Okay.
They use a small data set of examples to teach the model
Yeah.
how to reason in a clear and readable way.
So it's like giving it a basic foundation of logic and reasoning
Yes.
before letting it figure things out on its own.
Exactly.
Okay.
Then they move on to stage 2,
Yeah.
which is all about reasoning-oriented reinforcement learning.
Right.
This is where the model really starts flexing its intellectual muscles,
Okay.
tackling challenging tasks like math, coding, and logic puzzles.
And this is where that aha moment happened.
That's right.
The model starts showing signs of independent thought and creativity.
It's like they unlock something special in the model's abilities.
That's incredible.
Yeah.
What about stages 3 and 4?
In stage 3,
Yeah.
they use a technique called rejection sampling
Okay.
to refine the model's training data.
Okay.
They essentially have the model answer a bunch of questions,
Hmm.
but they only keep the examples where the model got the answer right
Right.
through a clear and logical chain of thought.
So it's like they're filtering out the noise
Yeah,
and focusing on the examples where the model truly demonstrated understanding.
exactly.
And-
Then, in stage 4, they hit it with one final round of reinforcement learning. This time focused on aligning the model with human preferences.
Right.
They want to ensure that the model is not only accurate, but also helpful,
Okay.
harmless,
Right.
and easy to interact with. But it's not just the training. They've also come up with some really clever tricks to boost efficiency and performance.
I'm really intrigued by this group relative policy optimization, or GRPO, that they're using. Could you explain how that works and why it matters so much?
GRPO is a way to train the model to constantly get better, to keep improving. It does this by comparing its current way of thinking, its policy, to its past policies.
So the model is constantly, like, checking itself, looking for ways to do better.
Exactly. And the group relative part means they're not just comparing individual policies, but groups of them. This makes the learning process way more robust and efficient.
So they're speeding things up by looking at the bigger picture, comparing lots of different approaches at once.
Exactly. And all that efficiency is a big reason why DeepSeek can train these powerful models for so much less money than everyone else.
Makes sense. But, DeepSeek R1 also uses this thing called mixture of experts, or MOE, and I think that's playing a big role in their efficiency and cost savings, right?
Absolutely. So think of it this way. Imagine you have a team of specialists, like, the best heart surgeon.
Okay, I'm with you.
You wouldn't ask that heart surgeon to fix a leaky faucet, right?
No, of course not.
MOE is based on that idea. It's like a model with specialized subnetworks, these experts.
I see. So not every part of the model needs to be activated for every task.
Exactly. You got it.
So if you need to solve a complex math problem,
You call in the math expert.
and if you need to, I don't know, translate something from Mandarin to English,
There's an expert for that, too.
so it's kind of like a Swiss Army knife of AI.
It's a great analogy.
And this is where those incredible cost savings come in, right?
Yeah.
Because the DeepSeek R1, it has all these parameters, something like 671 billion in total, but it only activates a small fraction of them during runtime, like, what, 37 billion?
That's right. So instead of using this massive model for everything, it only uses what it needs for each specific task. Super efficient.
That's pretty ingenious.
Yeah, it's a clever way to make this really powerful AI much more manageable and affordable.
No wonder it's got people talking. Now, you also mentioned this thing called distillation. DeepSeek is taking their big, powerful model and transferring its smarts to smaller, more lightweight models, right? Can you talk about that?
So distillation is basically teaching a smaller model to act like a bigger, more complex model. Imagine taking all the knowledge from, like, an expert and putting it into a simpler form that anyone can understand.
So they're making their AI more portable, more accessible.
Exactly. They've shown that they can take a large model like R1 and distill its reasoning ability into something that can run on a laptop or even a smartphone.
That's incredible. You could have an AI assistant that's as smart as those running on massive data centers, but without all the expensive hardware.
Exactly. This has huge potential to make AI affordable and accessible to everyone.
Makes sense. Anything else?
They also used low precision training, which means they used 8-bit floating point numbers instead of 32-bit. It's a bit technical, but basically they're using less memory without hurting performance.
So they're really finding ways to do more with less, which probably explains why they're so much more cost-effective than everyone else.
For sure. And then there's their use of chain of thought reasoning, or COTI. They built that right into the RL framework.
I've heard of COTI. It's like making the model show its work, explain its thinking process step by step.
That's it. By putting CoT into the RL setup, they're not just rewarding the model for the right answer, but for actually explaining how it got there.
So training it to think more like a human, breaking down problems and being able to explain the logic.
Exactly. And this commitment to efficiency extends to their choice of hardware, too.
Oh, really? What's so interesting about the
Oh.
hardware they use?
Well, DeepSeek achieved these incredible results using NVIDIA H800 chips. Now, those are less powerful than the top-of-the-line chips some of their competitors are using. They've also made some smart infrastructure optimizations, like mixed precision training and the dual pipe algorithm. But R1 isn't just about theoretical potential, it's proving itself on all sorts of benchmarks, often matching or even beating the performance of some of the most well-established models out there.
All right, let's take a closer look at those benchmarks then. What areas is R1 really shining in?
Well, in math, it scored an impressive 79.8% on the AM 2024, which is a pretty tough high school math exam. And on the Math 500 benchmark, it got a remarkable 97.3%. That puts it right up there with OpenAI's O1-1217 model.
It's amazing, especially for a relatively new model. R1 seems to have a real knack for mathematical reasoning. You mentioned earlier that DeepSeek is getting these results for way less money. How much cheaper are we talking, specifically?
Their API pricing seems to indicate that DeepSeek R1 is, get this, like 20 to 50 times cheaper to use than OpenAI's comparable model.
Wow, that's a huge difference. No wonder people are freaking out. What does DeepSeek's success mean for the big players like OpenAI, Google, and even NVIDIA, who makes all those expensive chips for AI?
I think DeepSeek has thrown a curveball at those companies that have been spending billions on giant data centers and their own proprietary models.
Yeah, if DeepSeek can do it for so much less, it makes you wonder if all that investment was really necessary.
Yeah.
Which has got to have NVIDIA sweating a little. Their stock is all about selling those pricey GPUs, and if people start training AI on cheaper hardware, that's a problem for them.
So, after some light editing, I was thoroughly impressed by the insights from the NotebookLM podcast hosts. I decided to test it via Perplexity. I posed the same question twice, once without DeepSeek R1 and once with it. Observing DeepSeek's thought process was fascinating. It felt like having an expert brainstorm right in front of me. The model deliberated on why the same question was asked twice, showcasing a deep and engaging reasoning process. One notable observation: while DeepSeek is significantly more cost-effective, its response time is considerably slower than current models. This is something to keep in mind when considering its application.